So hello everyone and very good afternoon. कैसे हैं आप लोग? I hope you guys have been doing good. Is audio video clear everyone? Is audio video clear? So hello everyone and very good afternoon. Please share it in the group that the class has started. Okay, we will start the session now. Then rest of the student will join later, and also you can watch this lecture on the recording also. So today is the third lecture for influence line diagram. Okay, we will start the lecture. In the remaining two lecture we have seen the influence line diagram for simply supported beam. Now in this lecture I will be taking the concepts for influence line diagram for cantilever beam. So in this lecture I will cover two concepts. Influence line diagram for cantilever as well as influence line diagram for the trusses. Okay. So most probably simply supported and cantilever will be asked in your examination. So keeping in mind the important concepts, we will finish the influence line diagram today. Clear? So today we will start with influence line diagram for cantilever beam. Okay. Is audio video clear? Please comment me. Is audio video clear everyone? Is audio video clear? Please comment me. Okay, we will start the session. Influence line diagram for, this is concept 2. Concept 2 is influence line diagram for cantilever beam. Cantilever beam has one fixed end and one free end. Okay, just a moment. So cantilever beam has one fixed end and one free end. So look, let us suppose this is your cantilever beam. This is the cantilever beam we're talking about. This is a cantilever beam. Understood? This is a fixed end. Okay, this is point A and this is point B. So how many support reaction can develop? How many support reaction can develop at fixed end? 3 support reaction can be developed at the fixed end. One moment, one Fx, one Fy. Yes or no? Clear? Okay. This is the ground. This is ground. This is cantilever beam. This is fixed at A. Now, influence line diagram means behavior of the load when unit load moves on the beam. Now look very carefully. First we will draw the influence line diagram ILD for reaction at A. ILD for reaction at A. Look very carefully. ILD for reaction at A. What will be the ILD for reaction at A? When look very carefully. If unit load moves in the beam, this is the unit load. When unit load moves from B to A, what is the behavior of the reaction at A? So what will be the reaction? Because of the unit load unit load, reaction VA will be developed and moment VA-MA will be developed. Moment and MA will be developed. Yes or no? Clear everyone? Now this is a unit load. Whatsoever be the position of unit load, the reaction at A will be 1 only. In order to balance this, in order to balance externally, to balance this unit load, what will be the reaction at A? What will be the reaction at A? It is 1 only. Whatsoever be the position of unit load, the reaction at A will be 1 only. Yes or no? Whatsoever be the position, if unit load is at here, VA will be 1. When unit load is at this position, VA will be 1. When unit load is at this position, VA will be 1. When unit load is just ahead of the support reaction, the reaction will be 1 only. So what will be the shape of ILD for VA? The shape for ILD for VA is nothing but rectangular and the magnitude is 1 only. Magnitude is 1 only. Clear everyone? So when unit load is at this position, VA will be this much. When unit load is at this position, the magnitude of VA will be this much. When unit load is at this position, the magnitude of VA will be only this much. Yes or no? Yes or no? Now, this is the way to draw the influence line diagram. Okay, this is the influence line diagram for cantilever beam. Now look very carefully. Moving ahead, what is the shortcut? Shortcut is given by Mueller-Breslau principle. Okay, Mueller-Breslau principle state that shortcut to draw the influence line diagram for cantilever beam is without removing the fixed end support. Without removing the fixed end support, remove the support and lift the beam by 1 unit. Remove the support and lift it by 1 unit. So what you need to do is, you need to keep this moment. Remove the fixed support and lift it by 1 unit. Lift it by 1 unit. If let us suppose, if we release this moment, the deflected shape will be on the slope. Since we are holding it and just removing the support, removing the support and give it 1 unit displacement, this will be the shape. This will be the shape. So according to Mueller-Breslau principle, according to Mueller-Breslau principle, remove the support. Okay, remove the support at A and give the unit displacement. Remove the support at A, remove the support at A and give unit displacement, remove the support at A or without releasing fixed end moment at A. Remove the support at A without releasing the fixed end moment at A. Without releasing fixed end moment at A. Without releasing fixed end moment at A. Remove the support at A and give unit displacement give unit displacement. Okay, this is the shortcut. The deflected shape of beam is the ILD for reaction. Deflected shape of beam is ILD for reaction. Understood everyone? Deflected shape for beam is ILD for reaction. So this is the first concept. In cantilever beam, how to draw the ILD for reaction? Remove the fixed support without removing the fixed end moment, displace it by 1 unit. The deflected shape of the beam is nothing but the shape of the ILD for reaction. This is the first concept. Understood everyone? Understood? Shall I move ahead? Okay. Now we will learn how to draw the ILD for shear force at A. What will be the shear force just at the right of A? Just at the right of A. Shear force is derived. So second concept. This is the first concept. Second concept is how to draw the ILD for shear force at RHS of A. So this is a cantilever beam. This is point A and this is point B. Okay. So this is a unit load. This is a unit load. So what are the reactions that are developed? This is reaction VA and this is bending moment MA. I need to draw ILD for shear force at RHS of A, at right hand side of A. Okay. Now look very carefully. If you need to find the at RHS of A, whatsoever be the position of unit load, always there will be the shear force at A. Now what is the sign convention for shear force? If you are looking towards the right hand side and there is a downward force, it is treated as positive shear force. So if unit load is at this position, shear force at A is 1. What do you mean by shear force? It is sum of all the transverse force, either from the left or from the right. So stand here, look towards the right hand side. How many forces are there? Only 1. So shear force here will be 1. If the unit load is at this position, again you see this, shear force is sum of all the transverse force either from the left or either from the right. So stand at A, look toward the right hand side. There is only 1 force, downward 1 unit. So shear force is 1. So what will be the shear force, ILD for shear force at A? Whatsoever be the position, the shear force at A is positive 1. Understood everyone? This is the ILD for shear force at A. I hope it is clear. This is the ILD for shear force at RHS of A. So this is the ILD for shear force at RHS of A. So according to Mueller principle, without removing the support at A, okay, without removing support at A, cut the beam at RHS of A. Then again the next step is, without removing the moment, give the unit displacement. Okay. Without removing the moment, without removing the moment, give unit displacement at A. Give unit displacement. Give unit displacement. Understood? Deflected shape is the ILD for shear force at RHS of A. Deflected shape is ILD for shear force at RHS of A. Okay. So without removing the support, cut the beam at RHS of A. Then here, without removing the moment, give the unit displacement. Give the unit displacement. So deflected shape of the beam is the ILD for shear force at RHS of A. This is the second concept. It is clear now? I hope it is clear. Now the next concept. So till now we have seen two concepts. What is the ILD for reaction at A? How to get the ILD for reaction at A? Remove the support. So same step we are doing it at the support. Remove the support, without removing the moment, give unit displacement. The deflected shape is ILD for reaction. Now for ILD for shear force at RHS of A, without removing the support, cut the beam at RHS of A, then give the unit displacement. Without removing the moment, give the unit displacement. The deflected shape is ILD for shear force. Now the third concept, for cantilever beam, how do we get the ILD for bending moment at C or bending moment at RHS of A? Next, third concept for cantilever beam is, this is a cantilever beam, this is reaction VA, and this is bending moment MA. This is bending moment MA. The length of the beam is L. Unit load. Clear? ILD for bending moment at A. ILD for bending moment at A. Now look very carefully. ILD for bending moment at A. This is point A. Now look very carefully. Bending moment is sum of all the moment either from the left or from the right. Sum of all the moment either from the left or from the right. When unit load is at B, what is the moment at A? Can you answer me in comment? When unit load is at B, what is the moment at A? Written everyone? Now look, when unit load is at B, look very carefully. When unit load is at B, what is the moment at A? What is the moment at A? Bending moment at A means sum of all the moment either from the left or from the right. When you are standing at A, look toward the right hand side. When you look toward the right hand side, what will be the bending moment due to this one load? 1 into L. And because of this force, what will be the bending moment? This will be sagging or hagging? This will be hogging bending moment. This will be hogging bending moment. Yes or no? So minus L, minus 1 into L. When unit load is at B, bending moment at A is equal to minus 1 into L. So minus L. Yes or no? Yes or no? When unit load is at A, when unit load at is A, what is the bending moment at A? When unit load is at A, when unit load is at A, bending moment at A will be equal to force into perpendicular distance. Stand at A, look toward the right hand side. Is there any force? There is no force. So what is the bending moment at A? That is equals to 0. So what will be the shape? It is decreasing linearly. If it is decreasing linearly, the shape will be something like this. The shape will be something like this. Look very carefully. Minus hogging bending moment. This is nothing but L. This is nothing but L. So look very carefully. When unit load is at B, bending moment at A is minus L. When unit load is at this position, what is the bending moment at A? This much amount. This much amount. When unit load is at this position, what is the bending moment at A? This much. When unit load is at A, what is the bending moment? It is 0. I hope it is clear. I hope it is clear. Yes or no? Clear? Understood everyone? So from Mueller-Bress, now from Mueller-Bress law principle, assume a imaginary hinge. Assume a imaginary hinge. So what is the rotation here is theta A. What is the rotation? What is the theta A? Perpendicular by base. This is 1. Assume without removing the support at A, assume a imaginary hinge and give a unit rotation. And give unit rotation without removing the support. Remove the fixed end moment. Assume a imaginary hinge and give the unit rotation. So from Mueller principle, what is the shortcut? From Mueller principle, without removing the support at A, remove the fixed end moment, assume an imaginary hinge and give a unit rotation. Without removing the support, okay, release the fixed end moment, 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 okay, assume an imaginary hinge, assume an imaginary hinge, assume an imaginary hinge and give unit rotation and give unit rotation. Give unit rotation, okay. The deflected shape of the beam is the ILD for, the deflected shape of beam is ILD for bending moment at A. The deflected shape of beam is ILD for bending moment at A. So three concepts we have seen for cantilever beam. I hope it is clear. Clear? Yes or no? So these three concepts are clear. For cantilever beam, how to draw ILD for reaction? Remove the support without removing the fixed end moment. Give unit displacement. The deflected shape is ILD for reaction. What is the ILD for shear force? Remove without removing the support. Cut the beam at A. Cut the beam at RHS of A, and without removing the fixed end moment, give the unit displacement. The deflected shape is ILD for shear force. Yes or no? And in simply supported beam, what was the concept in simply supported beam? For ILD for reaction, remove the support, give unit displacement. The deflected shape is ILD for reaction. For what is the ILD for shear force? Cut the beam on right hand side, displace the beam upside, and on left hand side displace the beam downward side, such that the total ordinate is 1. Yes or no? And how about bending moment? At any point, assume an imaginary hinge, give a displacement AB upon L, so that the total rotation is 1. Understood? That was the three concept in simply supported beam. Here in cantilever beam, remove the support, give the unit displacement. The deflected shape is ILD for reaction. For shear force, cut the beam at RHS of A without removing the fixed end moment, give the unit displacement. When for ILD for reaction, without removing the support, remove the fixed end moment, assume an imaginary hinge and give a unit displacement, give a unit rotation. The deflected shape is ILD for bending moment at A. I hope it is clear. Understood? Yes or no? Now we will try one question on this. Now you are given a beam. You are given with a beam. Draw ILD for bending moment at A. Draw ILD for bending moment at A. Draw ILD for bending moment at A. And the question is, this is a roller support and this is a free end, and this is an internal hinge. This is A, B, C and D. A, B, C and D, and the length for these are 3 meter, 2 meter and 2 meter. This is 3 meter. This is the question. Now, as per our concept, what we will do is, we will assume an imaginary hinge. We will assume an imaginary hinge at A, since we need this. We will assume an imaginary hinge at A. Now we will give a unit rotation. If we give a unit rotation, this is a internal hinge. This will go downward, and it is a free end. If it is a free end, this will also deflect this way. This is 3 meter, so this will be 3 meter. Yes or no? Yes or no? Clear, everyone? Now look very carefully how much this will go up, how much this will go up. If this is 2 meter, this goes down by 3 meter from symmetry. If this is 2 meter, this will go up by 3 meter. Yes or no? This is the ILD for bending moment at A. The deflected shape is ILD for bending moment at A. This is your answer. You have given a unit rotation at this point. Theta A is equal to 1. This will be 1 only when this will go down by 3 unit. Now if this distance is 2 meter, this goes by 3 meter. This distance is 2 meter, this also goes up by 3 meter. This is the ILD for bending moment at A. Clear? Understood everyone? Now the next concept for influence line diagram is, so before heading towards the next concept, first we will see one concept. One concept is this: I have one simply supported beam. Look, this is a simply supported beam. And a moment is there M. A moment is there M. Now look, in order to balance this moment M, what will be the magnitude of the reactions? If the length of the beam is L, can you tell me what is the reaction at A and B? If there is a unbalanced moment M, what will be the reaction developed at A and B? Look very carefully. There is a clockwise moment M. There is an unbalanced clockwise moment M. So at the reaction, at the support, anti-clockwise moment will be developed. How much will be the magnitude of these reaction? M upon L and M upon L. Understood everyone? M upon L and M upon L. Yes or no? Yes or no, guys? Clear? So what will be the bending moment diagram? What will be the bending moment diagram? If I see bending moment diagram where the moment is acting, the bending moment diagram will be somewhat like this. Stand at A, look at the right hand side. Which reaction is this? M upon L. M upon L reaction is this. So this will create a positive bending moment. This will create a positive bending moment. Yes or no? Yes or no? So the bending moment at A will be something like this. So bending moment at point A is M. So where the bending moment is this? Yes or no? This is the bending moment diagram for beam. This is bending moment diagram for beam. This is not ILD, this is bending moment diagram. This is bending moment diagram for beam. Now, if I replace this, if I replace the moment at the center, if I replace this moment at the center, look. Can you tell me what is the external support reaction? What will be the external support reaction? What is the external support reaction? External support reaction will be same. In the beam, externally, what is the unbalanced moment? Unbalanced moment is clockwise M. In order to balance it, what will be the reaction which is developed? Anti-clockwise M upon L. Anti-clockwise M upon L. Look very carefully. Anti-clockwise M upon L. Yes or no? Yes or no? Now, if I need to draw the bending moment diagram, the bending moment diagram will look like this. Look, we need to draw the moment. What is the bending moment? This is L by 2. M by L into L by 2. That is M by 2. This will be negative. Hogging bending moment M by 2. And when you need to draw the bending moment for this, stand here and look towards the right hand side. So this is M by 2. This is M by 2. M by 2 and M by 2. This is positive and this is negative. M by 2 and M by 2. You can see very carefully. So from this, what we can conclude is, we can shift the moment anywhere in the beam. We can shift the moment anywhere in the beam. The external effect will not change. External effect will not change. But yes, internal effect may change. You can see there is a change in the bending moment. There is a change in the bending moment. Yes or no? So you can see exactly under a couple or a moment, the bending moment is indeterminate. So that is why we find the bending moment just at the right hand side of the moment or just at the left hand side of the moment. So a couple can be moved in the beam. External effect, the reactions will not be changed, but internal effect, the bending moment will be changed. Clear everyone? So what is the inference? So from this conclusion, we will derive one concept. So a moment can be replaced anywhere in the beam. Okay. I hope you have understood this. How do we draw the bending moment and how we have drawn the bending moment? Yes or no? And you can see the external support reactions are same in both the cases, but internal bending moments are changed. Clear? Clear everyone? Yes or no? A moment can be replaced. A moment can be replaced anywhere in beam, can be replaced anywhere in the beam. Its external effect is same. Then its external effect that is reaction is same. External effect, yeah, reaction is same, but internal effect will be different. But internal effect which is bending moment will be different. Will be different. Will be different. I hope you have understood this concept. So exactly under a couple or a moment, bending moment is indeterminate. That is why we calculate ILD for bending moment at RHS or LHS. Okay. So exactly under couple or moment, bending moment is indeterminate. Bending moment is indeterminate. That is why we draw ILD for bending moment at LHS or RHS of couple of moment. Clear everyone? Have you understood the concept? So in strength of material, we have derived one concept that moment can be transferred anywhere in the beam. The reaction will not get changed. But yes, their bending moment will be changed. So from this concept, we will learn to draw the bending moment diagram. So we will learn how to draw the ILD when a couple is being moving on the simply supported beam. Understood everyone? Written everyone? Okay, we will move ahead and we will derive one concept. Okay, we will derive one concept. The concept says that, look, we will derive one concept. This is the beam, this is ground level. Now look, this is a unit moment. This is a unit moment. This is point C. This is 3 meter. Let us suppose this is 5 meter. 3 meter and 5 meter. Okay. This is a unit moment. Unit moment is traveling in the beam. Unit moment is traveling in the beam. You need to draw the reaction at ILD for reaction at A and B. You need to draw the ILD for reaction at A and B. Unit moment is traveling in the beam. If unit moment is traveling in the beam, clear? This is a unit moment. First we need to draw unit moment is traveling in the beam. ILD for bending moment, ILD for reaction at A. Look, ILD for, first we need to draw the ILD for reaction at A. Can you attempt this? Whatsoever be the position of this unit moment, what will be the reaction at A and B? What will be the reaction at A and B? So the unbalanced moment is clockwise. So the reaction developed will be anti-clockwise. 1 upon L, 1 upon 8. This will be 1 upon 8. Yes or no? Here also this is 1 upon 8. Yes or no? 1 upon 8. Yes or no? Reaction at A is 1 upon 8 and reaction at B is 1 upon 8. Have you understood this? according to the previous concept, whatsoever be the position of this unit moment, there will not be any change in the reaction. There will not be any change in the reaction. But yes, internal effect may change. Shear force and bending moment may change. Clear? Yes or no? Clear, everyone? So VA is 1 upon 8, VB is 1 upon 8. So whatsoever be the position of this, what will be the magnitude of reaction at A? This will be 1 upon 8 only. And if I need to draw the ILD for reaction at B, whatsoever be the position of this unit moment, the reaction will be same, that is 1 upon 8, negative 1 upon 8. You can take any one of the negative and any one of the to be positive. Let us suppose downward direction is negative. So what is the ILD for reaction at A? ILD for reaction at A, this will be negative 1 upon 8. This will be negative 1 upon 8. Negative 1 upon 8. So if the unit moment has this at this place, what is the reaction at A? This much. If the unit moment at this place, what is the magnitude of reaction at A? This much. Understood, everyone? This is the significance of influence line diagram. This is the significance of influence line diagram. So ILD for reaction at B. What is ILD for reaction at B? What is the ILD for reaction at B? ILD for reaction at B will be only 1 upon 8, 1 upon 8, and this will be positive. This is positive. Yes or no? 1 upon 8 positive. Clear, everyone? Yes or no? Clear? Now the third concept, ILD for shear force at RHS of A. ILD for shear force at C. ILD for shear force at C. Now look, you need to draw the ILD for shear force. If unit load is in between A and C, if unit load is between ILD for shear force at C, if unit moment is between A and C, what is the shear force at C? What is the shear force at C? If you stand at C, look towards the right hand side. If you see towards the right hand side, there is a reaction reaction 1 upon 8. Hello Suresh. So when the unit moment is between A and C, what is the shear force at C? Stand at C, look toward the right hand side. What are the forces? Only one force is this. And for any position of this unit moment, these reaction will not get changed. So what is the magnitude? 1 upon 8. 1 upon 8. Yes or no? On the right hand side, if there is an upward force, this is negative. So shear force at C is minus 1 upon 8. If unit moment is between C and B, shear force at C. Now look, when unit moment is between C and B, what will be the shear force at C? What will be the shear force at C? Stand at C, look towards the left hand side. है ना? Yes or no? Stand at C, look toward the left hand side. On the left hand side, if there is a downward force, this is treated as negative shear force. How much is the value? 1 upon 8. And whatsoever be the position of this unit moment, this reaction will not get changed. We have just taken this concept. So what is the shear force at C? Minus 1 upon 8. Minus 1 upon 8. So can we able to draw the shear ILD for shear force at C? It is 1 upon 8 only. It is 1 upon 8 only and negative 1 upon 8. Negative 1 upon 8. Yes or no? Yes or no, everyone? Yes or no? Understood, everyone? Now the last concept on this, in simply supported beam, when a unit moment is traveling, the behavior of reaction, shear force and bending moment. Now the third last concept is how to draw the ILD for bending moment at C. ILD for bending moment at C. ILD for bending moment at C. Now we will learn how to draw the ILD for bending moment at C. This is a simply supported beam. This is C, this is 3 meter, let us suppose, and this is 5 meter. Reactions are this is a clockwise moment, so a anti-clockwise moment will be developed. So this will be 1 upon 8, reaction at A, reaction at B is 1 upon 8 only. ILD for bending moment at C. ILD for bending moment at C. ILD for bending moment at C. Now look, how do we draw the ILD for bending moment at C? Case 1, when unit moment is in between A and C. So what is the bending moment at C? Bending moment means sum of all the moment either from the left or from the right. Stand at C, look toward the right hand side. If you look towards the right hand side, what is the bending moment at C? There is only one force, 1 upon 8. So what is the moment of this force at C? This will be 5 upon 8, force into perpendicular distance. And what is the magnitude? What is the magnitude? Because of this moment, this beam will rise up. So this is a sagging bending moment. So bending moment at C is nothing but 5 upon 8. This is positive. This is positive. And case 2, when unit moment is in between C and B. What is bending moment at C? Now this unit moment is between C and B. What is the bending moment at C? Stand at C, look towards the left hand side. Look towards the left hand side. So there is only one force, and this force is nothing but only 1 upon 8. So what is the bending moment at C because of this force? Minus 3 upon 8, hogging bending moment. Because of this, you can see the beam is hogging bending moment. So what is the bending moment at C? Minus 3 upon 8. Minus 3 upon 8. Understood, everyone? Yes or no? So positive 5 upon 8, and then at C this is indeterminate, and this is 3 upon 8. This is 3 upon 8 and this is 5 upon 8. this is positive and this is negative. I hope it is clear. Please comment me, is this clear? Yes or no? Is this clear, everyone? So six concept we have seen. Six concept we have seen in today's class. ILD for cantilever. So ILD for reaction in cantilever beam. ILD for shear force in cantilever beam. ILD for bending moment in cantilever beam. And the next concept is for simply supported beam. When a unit moment travels in the simply supported beam, what is the ILD for reaction at A, what is the ILD for reaction at B, what is the shear force at any point in the beam, what is the bending moment at any point in the beam. Yes or no? Understood, everyone? Have you understood these two concepts? Please confirm me, yes or no. Have you understood the shortcut for cantilever beam? Understood the shortcut for cantilever beam, yes or no? Now moving ahead. We will learn how to draw the bending moment. Now this is the another concept. Now the third concept is okay, before moving towards the third concept, that is the ILD for trusses, we will solve one question. One question, and look, this is a fixed beam, this is a cantilever beam. So question is, draw the ILD for bending moment at A. So the concept is, now look, find bending moment at A. The concept is find bending moment at A. Find bending moment at A. Find bending moment at A. Okay, for the beam shown in the figure. For the beam shown in figure. Okay, when it is subjected to UDL of 10 kilonewton per meter throughout its length. When it is subjected to UDL of 10 kilonewton per meter throughout the length. (10 kilonewton per meter throughout the length). Now this is the beam which is given. Look, this is a fixed support, this is an internal hinge, this is an internal hinge, then we have CDE, CDE. This is C, this is a roller support, this is again an internal hinge D, and this is a roller support again at E. So A, B, this is C, this is D, and this is E. This is the beam. And every distance is 2 meter. Every distance is 2 meter. This is 2 meter. This is 2 meter. This is 2 meter. This is 2 meter. Now solve it. Give it a try. Give it a try, everyone. Give it a try. You need to find the bending moment at A, and it is subjected to UDL of 10 kilonewton per meter. Now you need to find the bending moment at A. If we able to draw the bending moment, ILD for bending moment, it is easy for us to find the bending moment at A. Clear, everyone? Now we have just taken the concept for cantilever beam, or we can say at the fixed support. How to draw the bending moment? Assume an imaginary hinge. Assume an imaginary hinge and give a unit rotation. Yes or no? Give a unit rotation. Now if you rotate it by 1 unit, this is the internal hinge. This will also this will also be rotated, and this is also a hinge. A roller support is also a hinge. If, look, what will be the deflected shape? What will be the deflected shape? This much, and this will be goes upward, and this will come at this way. Yes or no? Assume an imaginary hinge at this point. Assume an imaginary hinge at this point. This theta is 1. If this is 2 meter, this will go down by 2 meter. This is 2 meter, this is also 2 meter. If this is 2 meter, this is 2 meter. This is 2 meter, this will also be 2 meter from symmetry. Yes or no? Yes or no? Understood? Without removing the support at A, assume an imaginary hinge and give a unit displacement. When you give a unit displacement, since it is an internal hinge, this will come downward. It is also a hinge. This will go upward. This is also a hinge. Without removing the support at C and E. So C and E is not removed. This is the deflected shape. So this is the ILD for bending moment at A. Clear, everyone? Now what is the bending moment at A? What is the net bending moment at A? If this much amount of UDL is moving on the beam, 10. So area under the curve, since all are symmetric, this is negative, this is positive. So net bending moment at A is is equals to, this is negative, this is positive. So negative half base into height. Half base is 4. Height is nothing but 2. This is area under the curve. What is the magnitude? 10. This is negative. And plus half base into height. and what is the UDL magnitude? This is 10. So net is 0. Net is 0. Yes or no, guys? Yes or no? So this was asked in one of the examination. I hope it is clear. I hope it is clear. Yes or no? I have given you the concept. Assume an imaginary hinge and give a unit rotation. The deflected shape will be the deflected shape of the ILD. This is the deflected shape of ILD. Clear, everyone? And the last concept. And the last concept for ILD is ILD for forces in the member of the truss. Last concept is ILD for forces in the member of the truss. From these lectures, okay, from these lecture, you can solve the questions of previous year question gate examination. You will be able to solve the question. Now, one thing I want to make clear is, okay, from these lectures, you watch these lecture and then try to attempt the previous year question of the gate examination. You will be able to solve the question. Easily you will be able to solve the question. Understood? Now, one thing I want to ask is, on which day you will be comfortable for the session of RCC? I want to take one lecture, one full-fledged lecture of 4 hours. That will be a lecture in that I'll complete the limit state method to design the beam. By limit state method, we can design the beam. On which day you will be comfortable? After tomorrow, because tomorrow I will be traveling to some place. After tomorrow, on which day? After tomorrow and day after tomorrow, except Sunday and Monday, except tomorrow and day after tomorrow, except tomorrow and day after tomorrow. It means except on Sunday and Monday. In the coming week, in which day you will be comfortable for this session, design of beam by limit state method? Are you comfortable on Wednesday? Are you comfortable on Wednesday? Yes or no? So this session will take only 2 to 3 hours. Okay, in one session I'll try to cover this limit state method design philosophy in 1 hour. Okay, I mean in one lecture I'll cover this. Will you be comfortable to attend this lecture on Wednesday in the morning session from 10 a.m. in the morning session from 10 a.m. Okay, you can comment me. Okay, you can send me the message on my number. You can discuss among your friend and you can send the message on my WhatsApp number. Clear? Now the next concept is ILD for forces in the member of truss. Last concept is ILD for forces in member of truss. ILD for forces in member of truss. This is the last concept for ILD. Now, when we draw a truss, let us suppose I draw a truss like this. when we draw this truss, this is only the one part of truss. This is only the one part of truss. This is just one part of the truss. Yes or no? But in actual, what happen is, when the unit load, we will show this unit load over here. It does not mean that unit load is moving on the truss. No. We have railway sleeper, we have rail line, then this is the front view. Now from the top, this is the front view. Now from the top, when you see that these are the two rails, these are 1.676 meter apart, broad gauge, okay, 1.676 meter apart. These are two rails. Below two rails, there are sleepers, okay. Below these two rails, there are sleepers. These are the railway sleepers. These are railway sleepers. Okay. Below the railway sleepers, there are stringer beams. There are stringer beams. Below the railway sleeper, there are stringer beams. These are stringer beams. So these green ones are stringer beams. Okay. So wheel load comes from rail to the sleeper, then sleeper to stringer beam. Then from stringer beam, we have cross girder, then it is transferred to truss. We have cross girders. Then from these are cross girders. And then these are cross girders. And from cross girder, these load transfer to the truss. These load transfer to the truss. Clear everyone? So from these load transfer to the truss. These are the truss. These red one are the truss. Understood everyone? Yes or no? So whenever unit load is in between this portion, half of the load is transferred and half of this load is transferred to this. Half of the load is transferred to this portion and half of the load is transferred to this portion. When the unit load is in between these member, okay. So when unit load is in between this, half of the load is transferred to this, half of the load is transferred to this. This is the concept. Now we will see a Pratt truss when a unit load moves. So this is a front view. We will show the unit load here like this, but in actual this unit load is moving on the rail. The weight is transferred from rail to the stringer beam, from stringer beam to this cross girders. Sorry, from rail to the sleeper, from sleeper to the stringer beam, from stringer beam to this cross girder, and from cross girder it will be transferred to the truss. Now look, ILD for, the concept is ILD for ILD for forces in the member of Pratt truss. ILD for forces in member of Pratt truss. In the member of Pratt truss. Pratt truss is also known as end type truss. It is also known as end type truss. End type truss. Now this is the truss which is given. This is a pad truss. Look guys. Look, this is a pad truss. This is a pad truss, or it is also known as end type truss. So U1, U2, U3. So upper members are being termed as U1, U2, U3, U4. This is U1, U2, U3, U4, U5, U6 and U7. And this one is L1, L2, L3, L4, L5, L6 or L7. Clear? When unit load is moving in the truss, what is the force in the member ILD for? You need to draw the ILD for force in the member U3 and U4. Force in the member U3 and U4. This is your task. This is your task. Now let us suppose this is 3 meter and these are 6 panel of 3 meter. 3 meter, 3 meter, 3, 4, 5 and 6. Understood? These all are a 3 meter. So when the unit load is moving on the truss, what is the nature of the forces in U3, U4? This is our task. This is our task. Understood everyone? Clear? Now look. For example, when unit load is moving in between L1 and L3, let us suppose this unit load is moving in between L1 and L3. So what is the forces in U3, U4? So your first task is when unit load is moving between L1 and L3. Okay. Look, when case 1, when unit load is moving in between L1 and L3. So let us suppose now this is a truss. So the truss have only the axial forces. Truss have only the axial forces. Let us suppose these are the forces. These are the forces in U3 and U4. Now cut the member at U3, U4. We will make a cut. We will cut it at 1, 1. Okay. So here the reaction, here also reaction VB, and this is VA. When unit load is between L1 and L3, look towards the right hand side of 1, 1. Look towards the right hand side of 1, 1. Look at RHS of 1, 1. RHS of 1, 1. If you look towards the RHS of 1, 1, how many? This is force in the member U3, U4. This is nothing but force in the member L3, U4, U3, L4. Okay. Now look, taking moment of all the forces on the right hand side about L4 is equals to 0. If the member is in equilibrium, sum of all the moment is equals to 0. Now when you are looking towards the moment about L4 is equals to 0, how many forces are there? How many forces are there? We will consider only those members which are cut by the portion. So this portion is cut, this portion is cut, this portion is cut. Yes or no? So let us suppose the force in this member is this and the force in the member is this. So what is the moment of these all forces about L4? The moment about of this force is 0, moment about this force is also 0. So which is left? FU3, which is left those force in the member. Now here clockwise moment is positive, anti-clockwise moment is negative. For example, we have considered this sign convention. What is the moment of this force about L4? From tail toward the head about L4. This will be nothing but anti-clockwise. So VB into how much distance? 3, 3, 3, 9. So VB into 9. This is VB into 9, negative. VB into 9, negative. And what is the moment of this force about this tail toward the head about this point? Again, it is anti-clockwise. So force in the member U3, U4, this height is 3 meter minus force in the member U3, U4 into 3 meter is equal to 0. Is equals to 0. So what is the force in the member? Force in the member U3, U4. U3, U4 will be equal to 3 times of VB. 3 times of VB. Yes or no? 3 times of VB. Yes or no? Now case 2. Case 2 is when unit load is in between L4 and L7. L4 and L7. Now look, now the unit load is somewhere at this location. Now you need to look at LHS of 1, 1. You look at the LHS of 1, 1. Why we are not looking towards the right hand side of 1, 1? Because this position may change at any point of time. But when you are looking towards the left hand side of 1, 1, there is no unit load. There is no unit load. So there is only one unknown force, VA. Okay. So look at LHS of 1, 1. Look at LHS of 1, 1. Now taking moment. Now here again, if you need to find out the force in the member, this taking moment about L4 is equals to 0. Clear? Or L3 is equals to 0. Let us suppose we have taken moment about L4 is equals to 0. Summation of moment about L4 is equals to 0. So how many forces are there? How many forces are there? At the left hand side of 1, 1, let us suppose this is one of the force. This is one of the force. This is one of the force. And VA is the force. So look. What is the moment of this force about L4? This is 0. What is the moment of this force about L4? It is also 0. So no need to take this. No need to take. So this force from tail. So here the sign convention is clockwise positive, anti-clockwise negative. So from tail towards the head. This is clockwise. Force in the U3, U4 into 3 meter. Force in the member U3, U4 into 3 meter. So VA into this, VA. From tail toward the head towards the L4 point. This is nothing but the clockwise. 3 meter, 3 meter, 6 meter, 9 meter. So VA into 9 meter plus 9 into VA is equal to 0. So this is second equation. Yes or no? So positive VA into 9. This from tail toward the head. Yes or no? Now from here you can see this. If you take this side, so minus 3 times of VB. Minus means whatsoever you have assumed. Minus 3 times of VB means you have assumed tension. When the arrow sign is away from the joint, it is tension. But since it is coming negative, so it means that this is compression. Here also you can see, here also force in the member U3, U4 is 3 times of VA, minus 3 times of VA. Minus means you have assumed arrow away from the joint. This is tension. But since negative comes, it means the force in the member will be compression. Force in the member will be compression. So how to draw the ILD for VA? How to draw the ILD for VA? How to draw the ILD for VA, guys? ILD for VA will be, how to draw ILD for VA? This is a simply supported beam. This is a simply supported beam. ILD for VA will be when force is in between L1 and L3. When force in between L1 and L3, what is the force in the member U3, U4? This is 3 times of VB. 3 times of VB. Yes or no? 3 times of VB means ILD for VB. Displace the beam by 3 unit. Displace the beam by 3 unit and the deflected shape of the beam is the ILD for reaction. This is 3 unit. And consider the portion from L4 to L7. Consider the portion from L1 and L3. Consider the portion from L1 and L3. This one. So this is considered. L1 and L3. Yes or no? Now, when the unit load is between L4 to L7, what is the force in the member U3, U4? 3 times of VA, minus 3 times of VA. What is the ILD for? What is the ILD for VA? Displace it by 3 unit and join it up to this point. So this yellow diagram is considered from L4 to L7. L4 to L7. L4 to L7. Yes or no? So this is the ILD for this. I'll highlight it. this much, and this one, and for rest of the position of unit load, join this one, so this is the ILD for moving load, and this is the ILD for force in the member U3 U4. So you can see very carefully, whatsoever be the position of unit load, the force in the member U3 U4 are compressive. So these are purely compressive member. Yes or no? This is 3 times of VB. This is 3 times of VA. This is the ILD for force in the member U3 U4. I hope it is clear. Yes or no? Clear everyone? Please give it a thumbs up if it is clear. Understood? Clear everyone? Now in steel structure, you must have studied that what is the maximum slenderness ratio for pure compression member. Now comes the steel. Since this is a steel member, these stresses are of steel member, this is a pure compression member. What is the maximum slenderness ratio for pure compression member? That is 300. And when a member is pure tension, maximum slenderness ratio is 400. Understood? Understood everyone? Member U3 U4 is pure compression member. Whatsoever be the position of unit load, there will always be a compression force in these member. Maximum slenderness ratio for pure compression member is 300. And what is the maximum slenderness ratio for pure tension member? That is 400. Understood? Clear everyone? At the last moment, this is sufficient. I guess this is sufficient. From these concepts only you will be able to solve the question. There are still few more question to be taken up, but you can solve the question by your own. Okay. And in one session we can take up the concept of limit state, design philosophy, limit state method, and we will learn how to design the beam by limit state method. Understood? This is it guys. You can revise the concept. Okay, you can revise the concept. Okay, this is it for today's class. Okay, from these concepts you can solve the previous year question. I have taken almost the important thing to become in examination. Okay. Okay guys, so we have taken the ILD for reaction, ILD for shear force, ILD for bending moment for simply supported beam, and when unit moment is traveling we have drawn ILD for reaction, ILD for shear force and ILD for bending moment. And for cantilever beam also we have seen what is the ILD for reaction, ILD for shear force and ILD for bending moment. Also we have seen how to draw the ILD for forces in the member in the truss. Yes or no? So this is it guys. Okay, this is it, and we'll meet after some days or probably on Wednesday. If you guys do not have any test on Wednesday, then probably we will meet on Wednesday, or you will get the message from the management. Okay, and in one lecture we will try to learn the design philosophies by limit state method. So this is it in today's lecture. Thank you so much guys, and thank you so much for attending the class live. And those students who were not able to attend it live, do watch this lecture in 2x speed or 1.5 speed. You will be able to find out the concepts very easily in a very less time. Okay, so this is it, and after watching this lecture, try to solve the previous year question of the GATE examination. We'll meet in the next lecture. Thank you so much. Bye bye everyone. And these are the last moment. Hello bhai Ashish. So these are the last moment. Your GATE examination are very close. It is my advice. Still sufficient time is left. Revise the concept and attempt the previous year question. So these are the last moment. Okay, try to have a better strategy. Do solve the previous year question of SOM. Do solve the previous year question of soil, environment. These are very important subjects. Soil, environment, SOM. Okay, FM, transportation, maths, aptitude and reasoning. So in the last moment, these are the subject which will give you the edge. Okay, thank you so much guys. We'll meet you in the next lecture. Thank you so much. Bye bye everyone.